Well, good afternoon, everyone. I hope everyone is doing well today. I'm Srijan. I'm a part of the Maths department from Angsh Academy. And today we're going to take up a simple question based out of your JEE exams. So let's have a look at the question, Hilary. So here's the question in front of you. A possible value of tan of 1 by 4 sine inverse of root 63 by 8 is what? Over here I have all the options. Of course, there are 4 questions over here, and out of these, one shall be correct. Now we'll try to find out. We'll try to figure out which one of them is correct, and we'll proceed with this question in a step-by-step way. This is indeed a question which has come in your or showed up in your JEE exams in the past, and let's go ahead and solve this particular question. So let's write down the question over here. Tan of 1 by 4 sine inverse of root 63 divided by 8. Now we'll have to figure out how to crack this question. So whenever you're seeing questions like this, there are some steps that are involved, and you need to figure out. You need to figure out how to figure out those particular portions, or to find out those particular portions. But first of all, the first hint that I see is this, an inverse function. So over here, sine inverse of something, of course, this is going to give you an angle, isn't it? If sine of, say, theta, or let's not say theta, let's use A, okay? If sine of A is equal to, let's increase the size of the scribble as well. If sine A is equal to, let's say, 1 by 2, then the angle A is going to be nothing but sine inverse of 1 by 2. So basically what we are trying to figure out over here is this angle first. So sine inverse of something, or anything at all, or tan inverse, cos inverse, all of the trigonometric ratios, an inverse of something will always give you an angle. So what I'll do over here is that I'll substitute this particular value first. So let's see what do I get out of here. I'll write this as tan of 1 by 4 theta. Theta is the angle that we'll be considering, and if I rewrite this, I actually get it as tan of theta by 4. So now we have a clear idea of what we need to find out. We need to find out the value of tan of theta by 4. So many of you will be thinking of finding out theta and then dividing it by 4 to find out that particular value of tan. But as you can see, the options, none of these options fall under the values that we already know about. Let's say 30 degree, 45 degree, 60 degree, 90 degree, and so on. So basically the value that I'm going to get is not one of those particular easier values that I can always find. So in this question, my idea would be to figure out the value of theta by 4. Considering theta by 4 is an angle, find out the value of theta by 4 itself. So here's how we're going to proceed. So the first thing that I did is that I've written it in terms of an angle. But now here's the substitution part. Theta is equal to sine inverse of, let's put a bracket over here, 63 root 63 by 8, isn't it? Now if we follow this process, we can also see that sine of theta will give you nothing but root 63 divided by 8. Now basically what you can do over here is draw a triangle and figure out the value of cos, but we're going to take up a shortcut because time is of the essence in your examinations. All right, so you have to mentally think about it as well. So I know the value of sine theta, so the value of cos theta is going to be nothing but 8 square minus root over 63 square, the whole under the root. So basically if I do that, I get the value of cos theta to be 1 divided by 8. If you're finding it tough, you can always draw a triangle and figure out the value of cos theta. This is the particular value that you'll be getting. Now, I know what cos theta is, but again, what I need to find out is nothing but tan theta by 4. So basically, I need to make sure the angle is being divided by 4, isn't it? So in these kind of cases, we'll be using certain formulas. For example, formulas which have twice a in it or twice theta in it. For example, I can relate cos theta and cos twice theta. This is how I'll relate it. So the formula is cos of twice a. You remember this? Cos of twice a can be written in 3 different ways, and you need to know what those 3 different ways are. This is one of them. Cos twice theta is equal to twice cos square a minus 1. Now if I consider twice a to be theta, then a becomes theta by 2. Now I'll just put these values over here, and if I do that, I get cos theta is equal to twice cos square theta by 2 minus 1. So from this, actually, I'm a step closer to my answer. And I'll get to know what the value of cos theta by 2 is by solving this further. So if I try to solve this, cos theta is 1 by 8. I'll take minus 1 to the other side, becomes 1 by 8 plus 1. And this is equal to twice cos square theta by 2. Now if I try to solve this further, if I take the LCM on the left hand side, I get nothing but 9 by, I'll do one step at once. Of course, it's 9 by 8, but I'll take 2 to the other side as well. So I'll get 9 by 16 is equal to cos square theta by 2. And from this, very easily, I get the value of cos theta to be nothing but, oh, it's not cos theta. It's supposed to be cos theta by 2 is equal to 3 by 4. Now I'm a step closer to the answer. I know the value of cos theta by 2. I need to go to the next step and need to find out the value of tan theta by 4. So again, we'll use the same kind of formulas. Cos twice a, tan twice a, sine twice a. All of these formulas, cos a and cos twice a are related. Similarly, sine twice a and sine a and tan twice a and tan a are related as well. You need to remember what all of those are. But for this question, I need to relate cos theta or cos of an angle with the tan of an angle. So if you remember correctly, again, we'll be using the formula cos twice a, because it's easier to remember it in this particular way instead of remembering it as cos a or cos a by 2. So from this particular formula, I get cos twice a is equal to 1 minus tan square a divided by 1 plus tan square a. So here if I substitute it again, but I'll substitute it a bit differently over here. What I'll do is I'll say that twice a is equal to theta by 2. I'll assume this. If twice a is equal to theta by 2, then a is nothing but theta by 4. Now if I replace or substitute all of these over here, I get it to be cos of theta by 2 is equal to 1 minus tan square theta by 4 divided by 1 plus tan square theta by 4. Now you see, I have only one variable over here, which is tan theta by 4. I know the value of everything else in this particular equation. So if you have one variable, if you have one particular variable and one particular equation, you can use that equation to figure out the answer. Now, if I go ahead and approach with this, I get cos theta by 2 is nothing but 3 by 4. And this I'm going to cross multiply. I'm going to do the entire thing in one step. I'll replace cos theta by 2 and then I'll cross multiply. So I get 3 by 4 plus 3 by 4 tan square theta by 4 is equal to 1 minus tan square theta by 4. This is what I get over here. Now what I need to do, I'll solve this further. Let's draw a line to separate it a bit. Okay, now to solve this further, what I'll do is I'll just take the like terms together. I'll take this to the other side and I'll take this to this side. I want to make sure that the terms are positive for easier calculation. So if I take 3 by 4 to the other side and subtract it from 1, I actually get 1 by 4. And over here, if I add these two terms, I get it to be 7 by 4 tan square theta by 4. The 4's gets cancelled out. The 7 goes to the other side. So what I'm left with is 1 by 7 is equal to tan square theta by 4. So I know the value of tan square theta by 4. So similarly, by looking at the options, tan theta by 4 shouldn't be nothing but this 1 by root 7. So as you see, we did a systematic approach, and once we knew the roadmap or how to approach it, we were able to figure out the answer. Like this, we're going to solve a lot more questions in the future classes. I hope you like